We will discuss about the DMA controller. So DMA stands for Direct Memory Access. It is designed by Intel to transfer data at the fastest rate. It allows the device to transfer the data directly to or from without any interface with the CPU. Using a DMA controller, the device requires the CPU to pull its data and address and its data address and control bus, so the device is free to transfer any data directly to or from the input. The DMA data transfer initiative only after receiving the hold acknowledgement signal from the CPU. So how does this DMA operations are performed? Following the sequence of operations. Initially, when any device has to send the data between the device and the memory, the device has to send DMA request to DMA controller. The DMA controller sends the hold request to CPU and waits for the CPU to access the hold acknowledgement. Then the microprocessor tries rates all the data buses, address bus, and control bus. The CPU leaves the control over the bus and acknowledges the hold request to the hold acknowledgement signal. Now, the CPU is in hold state and the DMA controller has to manage the operation over the buses between the CPU, memory, and input-output devices. Next, we will discuss about the features of 8257. So it has 5 channels. It has 4 channels which can be used to follow 4 input-output devices, and each channel has a 16-bit address and 14-bit pointer. Each channel can transfer data up to 64 kb. Each channel can be programmed independently, and each channel can perform read transfer, write transfer, and verify transfer operations. The generation mark signal peripheral device that 128 bytes has been transferred. It requires a signal phase clock. Its frequency range is from 250 Hz to 3 MHz. It operates in 2 modes, that is master mode and the slave mode. Here we will discuss about the pins that we found in the architecture. First of all, we have DQ, DRQ, Not to DRQ3. These are the 4 individual channels that DMA requested inputs, which are used by the peripheral devices for using DMA services. The fixed priority mode is selected. The DRQ has the highest priority and DRQ has the lowest priority among them. TAC, that is D acknowledgement, not to D acknowledgement 3, that is DACA not to DACA. These are the active low DMA acknowledgement lines which updates the requesting peripheral about the status of their request very simply. These lines can act as a strobe lines for the following devices. D.2 is they are the bidirectional data lines which are used to interface the system bus with the internal data bus of the DMA. In the slave mode, it carries command works to 8257, status was from 8257. Next is I4. It is an active low bidirectional tri-state input line which is used by the CPU to read internal registers of 8257 in this slave mode. In master mode, it is used to read data from the peripheral device during the memory write cycle. Next is IOW. It is an active low bidirectional tri-state line which is used to load the contents of the data bus to the 8-bit register. Next is clock. It is a clock frequency signal which is required for an internal operation of the 8257. Next one is reset. This signal is used to reset the DMA controller by disabling all the DMA channels. Next is A0 to A3. There are these are the 4 least significant address lines. In slave mode, they act as an input which selects one of the registers to be read later. In master mode, they are the 4 significant memory address output lines generated by 8. Next is CS. As we know, it is a chip select. It is an active low chip select line. In the slave mode, it enables read or write operations. In master mode, it disables the read or write operations. A4 to A7, as we discussed before, A4 to A3. These A4 to A7 are the highest number of the lower byte address generated by DMA in the master mode. Next is ready. It is an active high asynchronous input signal which makes DMA ready by inserting write state. HRQ, the signal used to receive the hold request signal from the output device. In slave mode is connected with DRQ. In master mode is connected with hold input of the signal. Next, hold acknowledgement, that is HLDA. It is a hold acknowledgement symbol which indicates DMA controller. The request has been granted to the requesting particular by the CPU, and when it is set next that is it is a low memory read signal which is used to read the data from the addressed memory locations during the DMA read cycles. And last part here is we have the pin configurations. You can see that we have discussed all the pins DRQ, not to Q3, and here we have data acknowledgement, and from data D0 to D3 right hand side you can find. And we have discussed about input output write, input output read, and memory read, memory write. Next we are going to discuss about the ADST. This signal is used to convert the higher bit of the memory address generated by the DMA controller into the latches. And AEN, as we know, this address enable. The signal is used to disable the address bus or disable the data bus. TC stands for terminal control. This is used to represent the DMA cycle to process the peripheral device. In the next lecture, we will discuss about the controllers interfacing with the microprocessors. Thank you.